Number 25. If liquid carbon disulfide reacts with 4.50 times 10 to the second milliliters of oxygen to produce the gases carbon dioxide and sulfur dioxide, what volume of each product is produced? So, carbon disulfide. Now, again, we're going to be doing a gas stoichiometry problem here, so we will need a balanced chemical equation. So let's start with our balanced chemical equation. Once we have that, we can probably just use the factor label method of dimensional analysis. We can use our crosshairs like we've been doing. But first, we need our balanced chemical equation. So carbon disulfide reacts with oxygen to produce carbon dioxide and sulfur dioxide. All right, let's get this balanced up here. So I have one carbon on this side, one carbon on that side. That seems okay. But there's two sulfurs on this side and only one on the right side. So I'm going to have to put a 2 in front of that. Right? And so that changes my number of sulfurs, but not my number of carbons. So that's fine. So how many oxygens do I have on the right side? I have 1, 2, 3, 4, 5, 6. So in order to balance number of oxygens, I'll need a coefficient of 3 on the O2. So I have a ratio of 1 to 3 to 1 to 2. Alrighty, so because I'm lazy, I'm just going to move this, I'm going to move this out of, you know what, let's not be lazy. Let's just leave it in scientific notation and see if we can do some work with that exponent. Alright, so we know that this much oxygen is going to react, okay? We don't know how much carbon disulfide is reacting, but we do know how much oxygen is reacting. So we're going to start there. So we'll go 4.5 times 10 to the second milliliters of O2. And we want to convert out of milliliters of O2 and go into, remember we have to do both, right? We have to do two gases here. And O2 will cancel right there. My answer will be in terms of CO2, right? And what's my ratio? CO2, 1. O2 is a 3. So let's do a calculation here. 4.5 divided by 3, 1.5. 1.5 times 10 to the second mils. Because I'm not going to do anything to change that exponent. So, ran out of room there. 1.5 times 10 to the second. You know what? I need another 0. 3 sig figs. Okay. Actually, you know what? I'm just gotta write that again. That looks pretty darn messy. 1.50 times 10 to the second milliliters of CO2. That one got a little messy. So you can do the exact same thing, right? That was for carbon dioxide. I need to do the exact same thing for sulfur dioxide. So I'm going to start with my 4.5. It's going to get a little bit scrunchy over here, guys, so bear with me. Starting with that same amount of O2, right? Because that's what the question told me to start with. And I'm going to convert out of my O2 and into my sulfur dioxide. And my ratio O2 is 3. For sulfur dioxide is 2. I can already tell it's going to be twice what that is. Right? Because it's a 2 to 3 ratio as opposed to a 1 to 2 ratio. So without even using a calculator, I could tell you. Oh no, sulfur dioxide, sulfur dioxide. All right, it's a little bit messy, but that's number 25.